Welcome back to another picoGym workout exercise video. In this video, we'll be walking through the binary exploitation challenge, clutter-overflow. Let's get into it. Clutter everywhere and not a byte to use. Okay, so they give you a netcat portal to connect to, and they also have a .c for a C source code file, and as well as its compiled executable, probably so that we can test it locally. Let's take a look at the program itself and what it's running here. So we'll connect to that. My room is so cluttered. What do you see? If we type in a bunch of crap, it says code equals 0x0, code not equal to 0x dead beef. Okay, so maybe we need to somehow override this code to be dead beef. Let's look at the C source code file here and see if we can't glean anything from it. All right, so we have the size, which is OX100, and I think that's around 256. So, and then we have a goal, which is, of course, dead beef. And then we can see that this is clearly a buffer overflow attack because their gets function is being used down here, which we know is susceptible to buffer overflows. Let's see what else. Okay, so yeah, here it's saying if code equals goal, then it will print out the flag for us. So we definitely need to override the code right here. Luckily, it actually tells us what the code will be if it triggers this else condition. So it'll tell us what our current code is and that it's not equal to our goal code. So that's nice. Normally we wouldn't have that much help for this, but anyways, let's go ahead and take a look at the executable itself. I have it right here in the Kali box. So let's first off try running a file on it. We see that it's a 64-bit ELF. Okay, now let's run GDB on it. And since we know this is a buffer overflow, we can do pattern underscore create. And let's do 420, blaze it. And we'll copy this. And we'll run the program. Then we'll paste in that cyclic data that we have so that we can actually figure out what the offset is for our buffer overflow. And if we look for RBP, we see that this is the pattern we want to look for the offset. So let's do pattern underscore offset and then just paste in that string. Found at offset 272. So that's where the, I guess, return address will be. So that may not be exactly what we want since we're trying to override a variable. But since it's kind of giving us the information we need by telling us what our current code is, then it is a very easy way for us to figure out what the true offset here is, right? So that being said, let's exit out of that, and we're going to go ahead and run Python, and we want to do from pwn import star, and then we're going to do p32, not p64, p32 on OX dead beef, because if we do p64, it'll give us some extra zeros that we don't need. Remember, we have to read this in Little Indian if we want to see it. And then we want to do A times 272, like so. And I forgot to surround that in quotes. All right. Let's exit out of Python. Oops. And let's go ahead and run GDB on the challenge again. Oh, also I forgot to show you that we do have a dummy flag here. Oops, I meant to do cat. We have a dummy flag here, so we know if it works if it prints out this flag. So let's go ahead and run, actually, we can probably just pipe this code into the executable itself. So let's do echo, and we'll do the A's first. And then we'll do the dead beef. Okay, and then let's run that. And as you can see, our code is 41414441, which is a bunch of A's, which means we went too far. So now we're just gonna go backwards in increments of 4. We probably could just go backwards in increments of 8 since it's a 64-bit program, but increments of 4 will actually kind of show us what's going on, so I'm going to do that instead. So if you see all those 41s, that means you went too far, and you're going to want to take off some A's. So let's take off 4 A's. Now let's run it. And now we see dead beef in the code, but then we see more A's as well. So that means we need to take off 4 more A's. See, there's 4 there. We need to take off 4. See why you could have done 8, you would have immediately gotten it. 1, 2, 3, 4. And then that worked. That gave us our flag. So now all we have to do is pipe that into the actual netcat portal. So let's copy that, and we're gonna actually, you know, it probably saved it. Yeah, there we go. And then let me paste that bit in, pipe it in, and there's our flag. Controlled clutter in my buffer. So we'll copy that, paste it in, and submit. All right, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave me feedback or questions in the comment section down below. This is Almond Milk. Thanks for watching. Goodbye, world.